Hello students, let us start the revision class. The chapter is Haloalkanes and Haloarenes. Let us see the questions one by one. Okay. First question is the UPAC name of this compound. This is CH3, CH, double bond CH, single bond CH-Br, CH3. Options: 4-bromo, 4-methyl butadiene. Option B, 4-bromo pentadiene. Option C, 3-bromo 1,3-dimethyl propene. And option D, 2-bromo pentadiene. In order to get the answer of this question, so this is a halogenated compound having a carbon-carbon double bond. So in this case, carbon-carbon double bond takes a higher priority than this halogen atom. So we can start numbering from the end that can give lowest number to the carbon-carbon double bond. It is a compound having 1, 2, 3, 4, 5 carbon atom. Start numbering from here 1, 2, 3, 4 and 5. So this is pentadiene. There is a bromine atom at the 4th carbon atom. So name of this molecule is 4-bromo pentadiene. So the option of this question is option B. Second one is your answer. Okay. Second question. Among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination gives single monochloride. Options A, neopentyl. Option B, isopentane. Option C, normal pentane. And option D, both A and C. Among the isomeric alkanes of molecular formula C5H12. C5H12, this is pentane. The isomeric forms of pentane. Pentane has the following isomeric structure. One is normal pentane, that is CH3, CH2, 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 CH3, it is normal pentane. Other one is isopentane. Isopentane is CH3, CH, CH3, CH2, CH3. And another isomer is neopentyl, CH3C, CH3, CH3, CH3. These are the three isomeric forms of C5H12. This molecule, normal pentane, has the number of halogenated compound depends upon the type of carbon atom. Normal pentane has primary carbons as well as secondary carbon. It is a primary carbon. It is a secondary carbon. It is another secondary that is different from this secondary carbon. So normal pentane produces 3 types of monochloro derivatives. Isopentane, it is primary. This is tertiary carbon. It is secondary and it is primary. This primary carbon is different. This primary hydrogens are different from this primary. So this isopentane produces 4 monochloro derivatives. Normal pentane gives 3 monochloro derivatives. Isopentane produces 4 monochloro derivatives. See, neopentyl. Neopentyl is this one. Neopentyl has 4 primary carbons. It has 12 primary hydrogens. All the primary hydrogens are identical. So this molecule neopentyl produces, neopentyl on monochlorination produces a single monochloro derivative, that is neopentyl chloride, or that is 1-chloro 2,2-dimethyl propane. So the answer of this question is option is neopentane, that is option. Neopentane, that is option A may be your answer. Neopentane is the answer. Okay. Next one. See the question once again. Neopentane is your answer, option A. Okay. Next one is, how many structural isomers are possible for the molecular formula C5H11Br? Options A 5, B 8, C 4 and D 6. Here, how many isomeric structures, how many structural isomers are possible? C5H11Br. C5H11 is pentyl group. This is the way to get the answer. It is pentyl group. Pentyl group is formed from pentane. When one hydrogen atom of pentane is replaced, you will get an alkyl group, that is pentyl group. Pentane may be normal pentane. Normal pentane is CH3, CH2, 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 CH3, normal pentane. It has 5 carbon atoms. 2 carbon atoms are primary, 3 are secondary. So how many monobromo derivatives can be formed? 1 bromopentane, 2 bromopentane, 1 bromopentane. Second one, another one is 2 bromopentane. And third one is 3 bromopentane. So from this normal pentane, you can have 3 isomers. From isopentane, CH3CH, this is isopentane. From this isopentane, you can have 4 bromo derivatives. 1 bromo 2-methyl butane, 1. 2 bromo 2-methyl butane, second one. 2 bromo 3-methyl butane, third one. And 1 bromo 3-methyl butane, 4 bromo derivatives can be formed. 1 bromo 2-methyl butane, 2 bromo 2-methyl butane, 2 bromo 3-methyl butane, and 1 bromo 3-methyl butane. And from neopentane, when one hydrogen atom is taken away from this neopentane, you will get one group, that is neopentyl group. So only one bromo derivative, here it is bromine, only one bromo derivative can be formed, that is 1 bromo 2,2-dimethyl propane. So number of structural isomers 3 from number of mono derivatives from normal pentane is 3, and from isopentane is 4, and that from neopentane is 1. So total number of structural isomers possible is 3 plus 4 plus 1, that is 8 structural isomers can be formed. So this is your answer. Option is B. Okay. Next is, which of the following is optically active? And option A, CH3, CH2, CH2, CH2Cl, that is 1 chlorobutane. Second one is option B, CH3, CH, CH3, CH2Cl, that is isobutyl chloride. Option C, CH3C, CH3, CH3Cl, that is tertiary butyl chloride. And the last option is CH3, CH2, CH.CL CH3, that is secondary butyl chloride. Optically active. Solutions of certain compounds can rotate the plane polarized light either towards right side or left side. That phenomenon is called optical activity. To be optically active, the essential, the necessary and sufficient condition is chirality. Chirality means the ability of a molecule to show non-superimposable mirror images. In the case of simple molecules, chirality arises due to the presence of a chiral carbon. A chiral carbon is one that is connected to 4 different groups. So optical activity in the case of simple molecules, optical activity is due to the presence of a chiral carbon. A chiral carbon is one. What do you mean by a chiral carbon? It is a carbon atom that is connected to 4 different groups. So you see in this case, among this here the halogenated carbon is not chiral. No chiral carbon is present here. Here also no chiral carbon. The third one is also there is no chiral carbon. In the fourth one, CH3, option D, CH3, CH2, CH.CL CH3. This is the compound given. Here the halogenated carbon, chlorine connected carbon is, this is the chlorine connected carbon. This carbon is connected to one CH3 group. It is connected to one ethyl group. It is that carbon is connected to one chlorine and hydrogen. So this carbon is connected to 4 different groups. Here one group is CH3, other group is ethyl, another one is chlorine, and other one is hydrogen. This carbon is connected to 4 different groups. It is a chiral carbon. So this molecule can exhibit optical activity. This molecule shows optical activity. So which of the following is optically active? In this, out of the 4 given compounds, the 4th one is optically active. So the answer of this option, the correct answer of this question is option D. Okay. Next one. Correct reactivity order of isomeric bromobutanes towards SN2 reaction is. Options: A. Normal butyl bromide has greater reactivity than isobutyl bromide, which is more reactive than secondary butyl bromide, which is more reactive than tert-butyl bromide. That is option 1. Option B. Tert-butyl bromide greater than, secondary butyl bromide greater than, isobutyl bromide greater than normal butyl bromide. Option C. Secondary butyl bromide greater than, tertiary butyl bromide greater than, isobutyl bromide greater than normal butyl bromide. Option D. Isobutyl bromide greater than, normal butyl bromide greater than, tertiary butyl bromide greater than secondary butyl bromide. C. Isomeric bromobutane, CH3, CH2, CH2, CH2. It is a normal butyl bromide. CH3, CHBr, CH2, CH3, secondary butyl bromide. CH3, CH, CH3, CH2Br, isobutyl bromide, and this one is tert-butyl bromide. These are the isomeric bromobutanes. These are the 4 isomeric bromobutanes: normal butyl bromide, secondary butyl bromide, isobutyl bromide, and tertiary butyl bromide. Here SN2 reaction. SN2 stands for bimolecular nucleophilic substitution. By molecular nucleophilic substitution, this reaction proceeds through the formation of a transition state. This reaction proceeds through the formation of a transition state. Therefore, reactivity of the alkyl halide proportional to the amount of transition state formed. That is important. Amount of transition state formed proportional to the reactivity of the alkyl halide, that is proportional to amount of alkyl halide that is proportional to the, that is reactivity inversely proportional to steric hindrance. That is very important. Lesser the hindrance around the halogenated carbon, greater the reactivity of that halogenated carbon, or you can say that in this case transition state is formed. Suppose this is the halogenated compound. Here carbon halogen bond is polar in nature. Nucleophile is in Assertion reaction. This is the way to get the answer. In Assertion reaction, the nucleophile is approaching to the halogenated carbon from the side opposite to the leaving group. So that approach becomes more and more smooth if the halogenated carbon is less hindered. Halogenated carbon is less hindered means readily that transition state will be formed. So you can remember this way, react in this is the capsule. Reactivity of halogenated compounds towards Assertion reaction follow the order primary alkyl halide, which is more reactive than secondary alkyl halide, which is more reactive than tertiary alkyl halide, or again you can say that methyl halide is more reactive than, less hindered primary alkyl halide, more reactive than, more hindered primary alkyl halide, more reactive than, less hindered secondary alkyl halide, more reactive than, more hindered secondary alkyl halide, more reactive than, less hindered tertiary alkyl halide, more reactive than, more hindered tertiary. That is a capsulized form. So here this is primary alkyl halide, this is secondary alkyl halide, this is primary alkyl halide but it is more hindered, this is tertiary alkyl halide. So which is more reactive? There are two primary alkyl halides. Less hindered will be more reactive. So 1, 2, 3, 4. So you can say that normal butyl bromide is more reactive than normal butyl bromide, that is more reactive than normal butyl bromide, more reactive than. Another primary is isobutyl bromide, isobutyl bromide, that is also primary but that is somewhat hindered than normal butyl bromide. So normal butyl bromide is more reactive than isobutyl bromide, more reactive than secondary butyl bromide, secondary butyl bromide, more reactive than tertiary butyl bromide. So here the correct reactivity order of the isomeric bromobutanes towards Assertion reaction: normal butyl bromide, more reactive than isobutyl bromide, more reactive than secondary butyl bromide, more reactive than tertiary butyl bromide. Let us see the question. Let us see the question once again. Normal butyl bromide, that is more reactive than isobutyl bromide, more reactive than secondary butyl bromide, more reactive than tertiary butyl bromide. So this should be your answer. So the option is answer is option A. Question number 5, answer is option A. And next question number 6, major product of dehydrohalogenation of secondary butyl bromide is very simple. Secondary butyl bromide CH3 CHBr CH2 alkyl halides undergo dehydrohalogenation when treated with alcoholic AOH. Alcoholic AOH is a dehydrohalogenating agent. Secondary butyl bromide, major product when it is during dehydrohalogenation, alkene is the product. CH2 CH CH2 CH3 plus CH3 CH double bond CH CH3. These are the two alkanes that can be formed during the dehydrohalogenation of secondary butyl bromide. Secondary butyl bromide on treatment with alcoholic AOH. That means secondary butyl bromide when treated with when subjected to dehydrohalogenation, two products may be formed, butanene and butadiene. Among these, more alkylated alkene is the major product. Among these, this is the more alkylated alkenes. It has 6 alpha hydrogen atom, 6 hyperconjugative structures, that is more stable. So the option of this question is answer option B. Option B is your correct answer. Correct answer is option B. Okay. Next question is, select the correct match. Here, first chlorinated organic insecticide 2 manufactured from carbon tetrachloride by Schwarz reaction. Third one, used as a feedstock in the synthesis of chlorofluorocarbons. And the fourth one is used as a metal cleaning and finishing solvent. You have to combine these with A, carbon tetrachloride, B, dichloromethane, C, freon 12, and D, DDT. See, the first chlorinated organic insecticide, that is DDT. 1, 2, 3, 4. First chlorinated organic insecticide is DDT. It is obtained by the action of trichloroethane, chloral with chlorobenzene in the presence of concentrated sulfuric acid. Its insecticidal action was proved by Paul Muller. Second one, manufactured from carbon tetrachloride by Schwarz reaction, that is freon 12. Carbon tetrachloride as Cl4. That on treatment with antimony trifluoride in the presence of antimony pentachloride, you will get CCl2F2 plus CCl2F2 plus SbCl3. Here when you equate this one, here 3, here it is 2 and 3. This is the balanced equation. So this reaction, chlorine atom of a molecule is replaced by fluorine atom. So this reaction is Schwarz reaction. So carbon tetrachloride on reaction with antimony trifluoride in the presence of antimony pentachloride, you will get freon 1, 2. So second one, manufactured from carbon tetrachloride by Schwarz reaction, that is Freon 1,2. Another one, third one, used as a feedstock in the synthesis of chlorofluorocarbon. Carbon tetrachloride is used as a feedstock in the synthesis of chlorofluorocarbons. And last one, used as a metal cleaning and metal finishing solvent, that is dichloromethane. So here first one goes to D, second one to C, third one to A, and fourth one to B. This is your answer. The correct answer of this question is option C. Okay. Next one is question number 8. We can go through some assertion reason type questions. Assertion is, and out of these in the following questions, statement assertion followed by statement A, statement assertion A, that is followed by statement of reason, that is R is given. Choose the correct out of the following choices. Here what you have to remember is, if both assertion and reason are correct, if both assertion and reason are correct, and assertion is the correct explanation, that you have to take that one, you have to mark that one as A. If both assertion and reason are correct and reason is not the correct explanation, then it is to be marked as B. If assertion is correct and reason is incorrect, then it is marked as C. If reason is correct and assertion is incorrect, then it is marked as D. Here the assertion is, electron withdrawing groups in aryl halides increase the reactivity towards nucleophilic substitution. Electron withdrawing groups in aryl halides are less reactive towards nucleophilic substitution reaction. That is because of the following reason. One is resonance effect. See, aryl halides are less reactive towards nucleophilic substitution. It is chlorobenzene. Due to resonance, carbon halogen bond has a double bond character. Because of that resonance effect, halogenated carbon has a double bond character. So that bond undergoes cleavage with very difficult form. That bond cleavage becomes very difficult. So haloarenes are less reactive towards nucleophilic substitution. Second one, in halogenated compounds, in haloarenes, halogenated carbon is, this carbon is sp2 hybridized. sp2 hybrid carbon is more electronegative than in alkyl halide. The halogenated carbon is sp3 hybridized. Due to sp2 hybridized nature, this carbon halogen bond becomes shorter. It is very difficult to cleave a shorter bond than a longer bond. So that bond becomes, cleavage becomes very difficult. And third one, because of the, see, when the nucleophile is approaching to the halogenated carbon, there will be stronger repulsion between the approaching nucleophile with the benzene ring. And last reason is phenyl, formation of phenyl carbocation becomes unstable. Because of that reason, because of these four reasons, resonance effect, second one, halogenated carbon is sp2 hybridized. Third reason, nucleophile experiences greater repulsion. And fourth one, phenyl carbocation is highly unstable. Because of this reason, because of these reasons, these haloarenes are less reactive towards nucleophilic substitution reaction. But when this halogenated haloarene has an electron withdrawing substituent, when this electron withdrawing substituent is there, suppose a nucleophile is connecting to this carbon, here it forms a carbanion, here there will be a carbanion, here there is halogen atom, here there is nucleophile, one carbanion will be formed. This carbanion will be stabilized by the pi electrons of the benzene ring as well as that electron withdrawing group. So electron withdrawing groups in aryl halides increase the reactivity towards nucleophilic substitution. That is very correct. Or you can say that reactivity of aryl halides towards nucleophilic substitution proportional to minus R effect, inversely proportional to plus R effect. So when more and more electron withdrawing substituents are in the haloarene molecule, that increases the reactivity of that molecule towards nucleophilic substitution. That statement is correct. And second one, 2,4-dichlorobenzene is less reactive than this is chlorobenzene. This is 2,5-dinitro, 2,5-dinitro, 2 in 2,5 or 2,4-dinitro. It is 2,4. Here it is minus R group. It is also minus R group. More the number of minus R group in haloarene, greater the stabilization of the carbanion formed. So 2,4-dinitrochlorobenzene is more reactive than chlorobenzene. That is the correct statement. Here what is given is 2,4-dinitrochlorobenzene is less reactive. This is wrong statement. This statement is wrong. This statement is correct. That means assertion is correct. Reason is incorrect. So here your option is C. C is your option. Assertion is correct. Reason is incorrect. So the option of this, the correct option of this question is option C. Okay. Next one. Another one, assertion reason type, neopentyl alcohol on treatment with concentrated HCl gives 2-chloro, 2-methyl butane. Let us see. Neopentyl chloride, that is CH3. This is neopentyl chloride. Neopentyl alcohol. This is neopentyl alcohol. Neopentyl alcohol on reaction with the HCl. When it is treated with the concentrated HCl, first step protonation, forming a carbocation. This carbocation is primary, that undergoes rearrangement by methyl shifter. So the most stable carbocation formed in this case is, this is the most stable carbocation formed. This will be attacked by Cl minus. So this is the product formed, that is neopentyl alcohol on treatment with concentrated HCl gives 2-chloro, 2-methyl butane. This statement is, this assertion is correct. Assertion is correct. Reason, stability of alkyl carbocations follow the order. Among the various alkyl carbocations, stability order tertiary greater than secondary greater than primary. So stability of alkyl carbocation follows the order tertiary greater than secondary greater than primary. So here there is a possibility of rearrangement. Hence rearrangement is possible that is because of that rearrangement 2-chloro 2-methyl butane is the answer. So here option, here assertion is correct. Assertion is correct and reason is correct, and also the correct explanation of that assertion. So both assertion and reason are correct. Both A and R are correct. Assertion is correct here. Reason is also correct, but reason is the correct explanation because there is a rearrangement of the carbocation. Both A and R are correct, and R is the correct explanation. So in this case, your option is A is your option. See the key answer key. Option A. Option A is your answer. That means correct assertion is correct, reason is correct, and correct explanation. That is very important. And we can familiar with another assertion reason type question. The dipole moment of CH3F is smaller than that of CH3Cl. Dipole moments of, that is very important, dipole moments of various methyl halides follow the order. CH3Cl has greater dipole moment than CH3F, which has greater dipole moment than CH3Br, more than that of CH3I. This is the correct dipole moment order of various methyl chloride. CH3Cl, the dipole moment of CH3F is smaller than, or CH3Cl is greater than that of CH3F. That statement is correct. The reason is what? Reason given is polarity of carbon halogen bond. Carbon fluorine bond is more polar than carbon chlorine bond. Carbon fluorine bond is more polar than, that is also correct, but that is not the correct explanation. Here why this methyl chloride has greater dipole moment, because carbon chlorine bond is greater than that of carbon fluorine bond. Carbon chlorine bond is longer than carbon fluorine bond. Dipole moment mu equals charge into bond length. Carbon chlorine bond has greater, longer, that is longer than carbon fluorine bond. Because of that reason, it has CH3Cl has greater dipole moment than CH3F. So here dipole moment of carbon fluorine bond is smaller than that of carbon CH3. Dipole moment of CH3F is smaller than that of CH3Cl. That statement is correct. Assertion is correct. Reason is correct, but that is not the explanation. So your option is, answer is option B. Option B is your answer. Okay. Next one. Another assertion reason type question. Chloroform is stored in dark colored bottles. Chloroform is CH.CH. It undergoes oxidation in air. It undergoes slow oxidation in the presence of light, giving COCl2, that is carbonyl chloride. Because of that reason, in order to avoid the slow oxidation of chloroform to poisonous compound phosgene, it is to be stored in colored bottles. That statement is chloroform is stored in dark colored bottles. That statement is correct. Reason is because it oxidizes to form phosgene, that is a poisonous gas, that is called carbonyl chloride or phosgene. Reason given here is chloroform is CH2Cl2. That statement is incorrect. Here this is incorrect statement. Assertion is correct, reason is incorrect. Assertion is correct and reason is incorrect. So the option is, see, this is your option. Option C is your answer. And next one. Next assertion type question. Alkyl chlorides can be best prepared by treating alcohol with SOCl2. Alcohol reacts with SOCl2. SOCl2 can be written in this way: thionide chloride. Alcohol reacts with SOCl2 to form RCl SO2 plus HCl. Alkyl chloride plus SO2 plus HCl. This is supposed to be the best method because other two products are escaping gases. It is a gas. It is also a gas. HCl is a gas. SO2 is a gas. Because of that reason, only alkyl chloride will be available in the medium. Okay. Alkyl chlorides can be best prepared by treating alcohol with the SOCl2. That statement is correct. Assertion is correct. Reason is SO2 is a gas. HCl is a gas. Here what is given as reason? Reason is order of reactivity of HX towards alcohols follow the order HI greater than HCl greater than HBr. That is wrong. Actually the order is HI greater than HBr greater than HCl. This reason is incorrect. Assertion is correct. Reason is assertion is correct and reason is incorrect. So the option of this question is, answer of this question is option C. Okay. Next one, we can go through some analogy type question. Alkyl chloride with the sodium and dry ether giving alkane. That reaction, what's reaction? Here chlorobenzene on treatment, sodium and dry ether giving biphenyl is formed. C6H5 C6H5 biphenyl is formed. That reaction is Fitig reaction. So the answer of this question is option B is your answer. Next one, the reaction of chlorobenzene with that is very simple. The reaction of chlorobenzene with alkyl chloride in the presence of anhydrous aluminium chloride is Friedel-Crafts alkylation. If so, the reaction of chlorobenzene with acid chloride in the presence of anhydrous aluminium chloride is acid chlorobenzene with acid chloride, that is chlorobenzene with acid chloride in the presence of anhydrous aluminium chloride giving, this is the product form. This is Friedel-Crafts. This is Friedel-Crafts acylation. This reaction is Friedel-Crafts acylation. So the answer of this question is option C. Next one is question number 15. The one, 2-bromobutane. 2-bromobutane with alcoholic KOH gives but2ene. While 2-fluorobutane or secondary butyl bromide with alcoholic KOH gives X. X is major product. This reaction takes place through transition state. Since carbon fluorine bond is strong, since it is very stronger than carbon bromine bond, here transition state formation is not possible. So in this case the major product is but1ene. But1ene is the major product. Option of correct answer of that question is option B. Next one, question number 16. The one, CH3CH2 MgBr Grignard reagent with water, phenyl magnesium Grignard reagent, ethyl magnesium bromide with water giving ethane, phenyl magnesium, this is a benzyl magnesium bromide with water giving X. You have to remember that Grignard reagent reacts with any molecule having acidic hydrogen to form hydrocarbon corresponding to that Grignard reagent. CH3 CH2 MgBr When it is treated with water, it is acidic in nature. This hydrocarbon part combines with the hydrogen to form CH3CH3 ethane. This is C6H5 CH2 MgBr benzyl magnesium bromide. Grignard reagent reacts with water. This benzylic part reacts with hydrogen to form C6H5CH3, that is toluene is the product formed. Option D. Option D is your answer. Answer is option D. Question number 17th one. In isobutyl chloride, the halogenated carbon is isobutyl chloride CH3CH2. It is isobutyl chloride. Here halogenated carbon is sp3 hybridized. sp3 hybridized. In allylic chloride, allylic chloride CH2 double bond CH2Cl. In allylic chloride, halogenated carbon is also sp3 hybridized. Allylic carbon is that carbon atom which is adjacent to the sp3 hybridized carbon adjacent to sp2 carbon atom of an aliphatic or alicyclic system is called allylic carbon. In allylic carbon, the halogenated carbon is sp3 hybridized. So the answer of this question is option B. Next is, you can go through the passage. From the passage given, you can answer the following questions. Alkyl halides undergo nucleophilic substitution reactions. Alkyl halides undergo nucleophilic substitution reactions through two different mechanisms, SN1 and SN2. In SN1 reactions, carbocation is formed as an intermediate. SN2 reaction takes place through the formation of transition state. Hence, reactions of alkyl halides towards SN1 mechanism proportional to stability of the carbocation. Tertiary alkyl halides undergo this reaction faster than secondary alkyl halide, which is more reactive than primary alkyl halide. Less hindered alkyl halides undergo SN2 reactions very readily. In an SN2 reaction, the nucleophile is approaching to the halogenated carbon from the side opposite to the leaving group. As a result, inversion occurs in SN2. While in an SN1 reaction, the carbocation formed will be attacked by the nucleophile from either side, hence racemization occurs. See the questions one by one. The order of reactivity of various alkyl halides towards SN1 mechanism. SN1 mechanism, reactivity of alkyl halide proportional to stability of the carbocation formed. You know that tertiary carbocation is more stable than secondary carbocation, more stable than primary. So this is your answer. Answer is option B. Next is 19th one. Which of the following alkyl halides is more likely to react through SN2 mechanism? Very simple. SN2 reaction reactivity order. Primary alkyl halide more reactive than secondary alkyl halide, more reactive than tertiary. Reactivity of alkyl halide towards SN2 reaction inversely proportional to steric hindrance around the halogenated carbon. Among these, the least less hindered one is 2-bromo-2-methyl propane, 2-bromobutane, 1-bromobutane and 1-bromo-2-methyl propane. Out of this one, the less hindered one is 1-bromobutane is the less hindered halogenated compound. So that undergoes SN2 reaction more readily. Option C is your answer. And the last question, the reaction of an optically active halide through SN2 mechanism results in SN2 reaction. The nucleophile is approaching to the halogenated carbon from the side opposite to that leaving group. As a result, there is a complete inversion. If the optically active halide, reaction of an optically active halide through SN2 mechanism results in complete inversion of configuration. Complete inversion occurs. Option A is your answer. Thus, I discussed some most important questions that you can expect for your coming examination. You have to go through these questions again. Wish you good luck. Thank you very much.